This is Chain of Thoughts, an original podcast by Arionkoder that covers the latest trends in product and AI. In Chain of Thoughts, every show is an element of a chain, connecting product with AI and AI with product. From understanding a brand new machine learning technology to covering the newest experiences around product and design, Chain of Thoughts keeps the chain growing with the thing that we value the most, our thoughts. Chain of Thoughts is an original production by Arionkoder, a product design and development company based in Boston, Massachusetts, that delivers specialized services around engineering, product, and AI.
Well, welcome to today's episode of Chain of Thoughts. This is going to be a pilot, let's say, so let's see how it goes. Well, you have already heard the intro. You know that the idea of this podcast is to connect our thoughts, connect the thoughts that we have around AI and the thoughts that we have around product, and think a little bit together about how AI is impacting this world. So it's not going to be just me on this podcast. It's going to be the three of us. So we will introduce ourselves. I will start, if you're okay with that. I'm Nacho Orlando, Jose Ignacio Orlando, but everyone call me Nacho, like the chips. I have to make that joke always. I'm a software engineer. I'm also a PhD in applied mathematics. I'm the director of the AI labs at Arionkoder. I'm also a professor at the university in Argentina. I am a researcher in AI as well, and I'm representing the nerd team, the AI team in this podcast. And with me, we have Vico and Calde. Both of them will be part of this podcast as well. So you are not talking yet, so please introduce yourselves. Vico?
Sure. Thank you, Nacho. So everyone calls me Vico. I actually come from business background, more into consulting for some years and facilitating cross-disciplinary teams. My different lives have taken me from international affairs, more investment consulting and business consulting, into anthropology. That's actually going to be hopefully my contribution to this podcast too, and seeing how as human beings, communities, and society, we collaborate into building images of the future and building innovation together. So that's a little bit of me. And looking forward to what we will be able to discuss in today's episode.
What about you, Calde?
Okay.
Tell us who you are.
Hi, I'm Calde. I have a background in design, and I've been working as a product manager for more than 10 years. And I have a particular interest lately in how UX and the user experience in general will change with all of these series of changes, right? That LLMs and AI in general are bringing to the field of technology.
That's awesome. So it's going to be the three of us in most of the episodes, but the plan is to have also some interviews. So it's going to be amazing. And it's just a matter of sharing and, well, all the things that you always say when you are recording a podcast. So before starting with the actual topic of this edition, while we see Vico sneezing, is before moving forward, I'd like to know, guys, what you're expecting from this podcast. So what are your thoughts? What are the thoughts that you have that will be changing Chain of Thoughts?
Well, I think it's really interesting to see how LLMs currently, and also all of the things that are happening with AI, are kind of reshaping the way we see technology and the way we work with technology. So it's I really think that it would be like thinking together. It would be like more like putting our ideas together, contrasting them, and getting to new ideas from that. And I would love to see that happen, right? That we create new ideas here while recording the podcast.
That's great. What are your thoughts, Vico?
I'm kind of really on the same line, together with building shared languages. And I wanted to say about shared languages, and it's funny because today we're talking about large language models. It's also exploring the boundaries between what is and what is not that will help us actually entertain much more significant conversations. It is said that we understand these things through the boundary of what it is and what is not, right? We have like the contrasting views to help. I think that will help us all to explore and actually navigate and build together different possibilities in the future. So it's more like building, as Candace said, a shared understanding that will help actually grow new opportunities and ideas, not only for us, but hopefully for those who are listening too.
Yeah, that's great. My thought is that this could be an excellent place for all of us that we are recording, all the people that is recording this episode to learn from each other. That's something that I love to do, and I think that that is going to be great, not just for us, but also for the people who are listening to us. I think that by sharing the things that we know, the things that we are learning as well, and the things that we don't know, we will somehow help our listeners to learn more. And I think that's an important part. At the same time, I really believe that contrasting our ideas, as Calde was saying, is an important part. We are in front of a technology that is reshaping the world mostly, and I think that sharing our vision on how the world will evolve thanks to this technology and how we are expecting the world to evolve, it's also interesting from this perspective. So yeah, I'm really looking forward for this to be fruitful for our listeners. I'm quite certain that this will be fruitful for us as well. So yeah, let's make it happen.
So today we're going to be discussing about LLMs, going from the basic what LLMs are, how do they work internally, also going to the basics around training, fundamentals, a little bit about fine tuning. We'll discuss also a little bit about ownership of LLMs. We know there's something that we should dive this, and about learning curve. I know many of you that are there thinking about products. This is something you would like to understand better together with some applications of LLMs. And hey, we couldn't be product team in this podcast without talking about how do we balance LLMs in product design? How do we include them in our practice? How do we build shared languages to collaborate even with machine learning engineers? And as this wouldn't be a podcast with Nacho involved if we didn't talk about ethics and LLMs. And to close about this, of course, lastly, future trends is what we're going to be talking about. How will LLMs evolve in the coming years? So make sure to stay tuned in all the way to the end to hear about this. And now let's start from the very top. And Nacho, please do help us through what are indeed LLMs in the end.
All right. So when I have to teach and based on a name, what I usually prefer to do is to decompose the name into its pieces. So if we call about an LLM, we talk about a large language model. So let's decompose it in three parts. First, we have the model. All right. So we are talking about a machine learning model. We are talking about an algorithm that is learned from data, right? We can dive deeper if you want, but let's just think about it as a black box that was learned from a database. The second thing is that it's a language model. This means that is a model that is able to recognize, translate, predict, generate language, right? And for doing that, it has learned from data the properties of the language, let's say, the patterns that are hidden in the language, the probability distribution, if we talk in mathematical terms. And the third element of the definition is that it's large. And by large, we mean that it's a model that has billions of parameters. The fact that it's big and large is the important concept here. When we talk about an LLM, we are talking about a model that has so many parameters that it's able to model those complexities of the language, all those properties, all those intrinsic patterns that are hidden in the language that we as human beings are able to dominate, but that for a machine to dominate gets more complicated. So in a nutshell, we're talking about a machine learning model with billions of parameters that were used to model the language. If we want to go deeper in terms of which kind of model we are talking about, we are referring to a deep learning model, which is a specific type of machine learning model that is based on deep neural networks. And yeah, and I think it's also important to understand that these large language models are in general generative models, which comes in opposition to what a discriminative model is. So if you think about it, a discriminative model is a model that can make a decision out of data. So if you feed it with a sample, it's able to classify it or to make a decision out of that. For example, I don't know, you provide a picture of an animal, and the model is able to recognize whether it's a cat or a dog, for example. That's a discriminative model. A generative model is different. A generative model is able to generate data. In this case, a large language model is, in general, able to generate text, right? So that's a definition, I would say. That's a large language model. It's a machine learning model, a deep learning model that is generative and that is able to model language.
And you say it's like a black box, but how do they work internally?
Well, it really depends on the type of large language model that we have in front of us. But I would say that most of the modern architectures of deep neural networks, well, first of all, a machine learning model, a deep learning model, is based on a neural network. And a neural network has a specific architecture. By architecture, we mean the way in which the different layers of this neural network are organized. And in the particular case of the large language models that are so popular right now, like GPT or Llama or Mistral models, these are based on the transformer architecture, which has nothing to do with a car that can turn into a robot. When we talk about a transformer, we are talking about, as I said before, a deep neural network architecture that was published in 2017, so a few years ago, by Google. It was a paper by Google. And the name of the paper is quite funny, is Attention is All You Need. Because they realized that by designing this neural network in a specific way, they were able to bypass some of the problems that the most popular models by that time, which were the LSTMs, weren't able to bypass. So this architecture has a specific thing, which is a component that is able to model the relationship between one word with every other word on the input. And by learning that, you learn, well, first of all, you have more context, right? Because now when the model is analyzing a sentence, it's not analyzing just a few words altogether, but the entire input at the same time. And as a consequence of that, these architectures were able to produce LLMs that produce better outputs. So yeah, in a nutshell, the most important component that makes these LLMs work is this architecture, this transformer architecture. And actually, if you decompose the acronym GPT, it stands for general purpose transformer. So the T of GPT is actually a transformer. And another important factor around how these LLMs work internally is this massive parameterization, the fact that it has millions of parameters that are organized in these layers. So it's not just a matter of the amount of parameters that these models have, but the way in which they are organized. So for example, when it comes to an LLM, there's always an embedding layer. This embedding layer is a layer that takes text as an input and produces a vector representation of that input. And in general, this vector representation contains the semantics of the text that you are introducing, which is amazing. I mean, there are some embeddings models in which you can do arithmetics directly on words. So for example, if you have the word king and you sum the word female, I mean the representations, the embeddings for those words, then you get a new embedding that translates to the word queen, for instance. If you sum female and king, you get queen. And that's amazing. And that was like the first evidence that we had about capturing the real semantics of the words within a machine learning model. And then there are other layers involved, other neural layers involved in these models. We are talking about feed-forward layers. There are around, that were around for the last 80 years, I believe. Recurrent layers, which are the ones that allow the model to model sequences. And of course, this attention mechanism that we talked about that is able to model the relationship between the different words in the input.
That's very interesting. And why don't we dive then a little bit into the basics around training this and what are the fundamentals? Like for those less familiar with AI, could you explain basically how it's the basic of LLM trainings and why are they so revolutionary right now? And what is so special about it?
Yeah, I think that the special thing is that it's a trick, But before talking about the trick for training these models, let's first define what training a machine learning model is, because I guess that some of our listeners will come from the product area and would like to know a little bit more about this. So when we train a machine learning model, we need basically 2/3 elements. First, we need the training data. When we talk about training data, we are talking about samples that model a task, the task that we want the machine learning model to solve. Then we need a cost function, an objective. And by cost function, we mean a mathematical function that allows us to measure the degree of error that the model is committing every time that we feed with a training sample. And this is helpful for the model to improve itself and to learn how to model this task. And the third component is the optimization process. This optimization process is an iterative process that lets the model to give it a try on each training sample, produce an output, and then pay a cost based on this objective function. So every single machine learning model is always trained in the same way, from the logistic regression algorithms that were invented in the 60s and that were used by statisticians in all the world, to these complex transformers that are in the background or inside the LLMs. But in the specific case of the LLMs, I think that the magic is behind the trick that is used for training. So most of machine learning models are usually trained in a supervised learning way. This means that in our training data, we have the samples and the output that we are expecting to get from that input sample. But and this is fine, but you can guess that the main problem with that is that collecting a data set full of samples with a label, a target label, involves a human labeling the samples, and that makes the process quite expensive. So the alternative is what is called unsupervised learning, in which you just take the inputs and try to learn something out of that. That's something that, for those that come from a machine learning background, that's how clustering algorithms are trained. Let's say they are not trained, but you got me. And the trick here is what is called self-supervised learning. So self-supervised learning is an active field of research. We are talking about models that are able to learn by themselves based on a pretext task. So, for example, we as humans. So let me ask you a question. How do you believe that we as humans learn to walk? It's a
I
tricky
think
one.
it is,
Yeah,
yeah, but I think it's a lot of observing and experiencing the real world, right? I think it's a combination of observing and experiencing.
exactly. Yeah, it's very similar to that. So, of course, there's a difference, because when we are children and we are learning how to walk, we fail and we have some negative reinforcement every time that we hit
Right.
ourselves, right? In this case is a little bit different, but uh, a self-supervised learning model is able to learn automatically from a pretext task. That's the funny thing around these models. They are trained in a way that is not, they are trained for doing a task that is not exactly the target task that we have, but that is helpful to get what we want. So in this case, the trick is a task that is called masked language modeling, which is essentially taking a piece of text, removing a word, and asking the model to find what was the missing word. And this is, if you think about it, that's something that you can do with all the text that we can find on internet at zero cost, mostly, because you just need to take as many texts as possible, remove random words from that, and then iteratively ask the model to find a way to find a word that is missing. And there are some other tricks, like there's another option that is called next sentence prediction, in which you basically take a sentence, then extract a random sentence from somewhere else, and you ask the model to answer the question, is this the next sentence of the text or not? And then based on that, the model is able to learn by itself this relationship.
From what
um,
you're telling me, actually, I'm thinking on learning a new language for humans also, right? Like
mhm.
it's similar to the exercise that we have in books when we learn English or Spanish. It's similar to that, right? You just have to complete a sentence or understand what would be like the next sentence, how to answer in a proper way to a question, right?
I would
Mhm.
love
Yeah,
filling the blanks exercise.
Yeah.
yeah, exactly. It's just filling the blanks. And what really amazes me the most is the fact that this is not very complex. If you think about it, the idea is super straightforward. It was just a matter of plugging that on a very big cluster, with lots of GPUs, and being able to train something like that humongous model. But yeah, the idea is very, very, very simple. And so yeah, the way in which these LLMs are trained is that they have billions of parameters, because they need to solve this complicated problem of figuring out what's the missing word. um, and they are using these parameters to somehow learn the complexities of the language and all the hidden patterns. And they are trained in an autoregressive way, which means that they produce an output. So they are fed with a sentence with a last word missing. They predict the missing word, and the next step is to take this new sentence with the missing word as input, and try to produce the next one, and so on and so on and so on. And that's the generative component of the model, because now you get something that can be fed with its own answer and try to prolong the sentence until reaching a point. And you know what, that point is another word, but it's a word that is dedicated explicitly to finish the sentence or to finish the text. It's just a token. It's just something that lets the model, that lets the user of the model stop the generation. So yeah, that's how these models are trained. Super easy.
I was last thinking of that. You said it's like a really straightforward approach, basically fitting in like super powerful computing power and a huge data set. How
Hmm.
huge are we talking also? Because we're seeing this is simple, but how big of a data set have these models been trained with?
Well, the best models that we have right now, and this is something that comes more around the who owns the LLMs and that debate, but the big models that we have available right now are trained on big data sets, and that's the only information that we have, that they are trained on big data sets. We don't have even an order of magnitude. We don't know the details. What I can tell is that depending on the amount of parameters of the model, then the size of the data set that we need for training, because otherwise we can enter in a regime that is called overfitting, which is when a model memorizes, so to say. We are not talking about models that have memory abilities, but you get my point. Models that are able to solve the task perfectly on the training data, but when they are evaluated on new unseen samples, they fail. They suck on that new data set. So in order to avoid the problem of overfitting, you need to train the models in humongous amounts of data, so that they know so that they know how to generalize to any other context.
So let's say
Yeah, go ahead.
you want to use, right, one LLM model for a particular thing, right, like for a custom application, right?
Mm-hmm.
Do you have to create a new large language model, or how is that happening?
Well, it really depends on the target application. So an LLM is what is called a foundation model. A foundation model is a model to rule them all in Lord of the Rings terms. It's a model that has such a huge amount of parameters and was trained in such a big data set that it already learned some important patterns that can apply to many other problems. That means that you don't need to train a monster like this every time that you want to swap from from one application to another, but just doing a fine tuning, and sometimes not even that. But anyway, on a smaller data set. So by fine tuning, we mean, instead of retraining the whole thing, which is computationally expensive, that requires a big data set and this thing, we're talking about just using a small representative data set of the task in hand, and retrain only a few layers of the model. Again, you can say, all right, if you needed, I don't know, 1,000 GPUs for training these models, then how can you do the fine tuning if you don't have 1,000 GPUs? Well, there are some tricks. The scientific community has introduced some tricks. There is one that is being quite popular right now that is called LoRA, which is a female parrot in Spanish, but it stands for Low Rank Adaptation of AI Large Language Models, which was published by Microsoft. I think it was 2 years ago or 1 year ago, in which you basically end up freezing some parameters of the model. So this means that they remain untouched, that you're not doing anything. And you just add a new set of only a few training parameters that are the ones that need to be adapted. So in the essence of this algorithm is just finding a mathematical trick to, instead of feeding the entire monster into 1,000 GPUs, just feeding a tiny bit and optimizing that small part that needs to be corrected. And there are other techniques like adapters and things like that that were also invented to allow fine-tuning these LLMs. But in practice, sometimes you don't even need to do that. Sometimes you just need to prompt the model in an efficient way. By prompting, we mean instructing the model or using an input that gives instructions about the task that you want to solve, or just fine-tuning for a while on a smaller data set and see what you can get. The most typical example is when you want to take one of these foundation models to a very niche application. For example, I don't know, medicine. You want to have a large language model that knows about different conditions and I don't know which medicines or drugs can be administered to a person who suffers from a specific disease. So of course, maybe in the original training set of the foundation model, you already had some information about that, but it's going to be lost in between information about cats and dogs and politics and the constitution of the US and things like that, right? So how to make it focus on that specific part? Well, you can download as many medical papers as you can collect from internet and then train the model in this masked auto-encoding way and then move forward.
Great. Okay, what? Go ahead.
Okay. Sorry, we're thinking maybe on the next point. There are two big legs we could take from the point we discussed up until now. One is we talked about the computational demand of training these models, and you already give a hint of this topic about ownership around LLMs at the beginning of the conversation. We're talking about the requirements of training this and who are the owners of this then in the end. And that's the first door that we have there. And then a few intakes into you left a hint there about talking about prompt engineer, but let's do a pause before going into more into the learning curve into this. The ownerships are in the end of these LLMs today, and who are them? And because it seems only a few companies, and we are well aware of some of them, can actually have the privilege, let's say it in this way, actually, to basically train them because of these requirements.
Yes, we talked about the two main needs that we have when we want to train a large language model, which are the training set, the big training set, aka internet, and the computational demand of training that. You need high performance computing infrastructure to train these big things with thousands of GPUs, and that's prohibitive. And that's why we are seeing that all these models are produced by big companies like Microsoft, OpenAI, Meta, and so on and so forth. So Google as well. So yeah, you need to have access to those training facilities, and that's something that is prohibitive right now, and that's why we are seeing a shift, let's say, in the scientific production around these big models. We are seeing that the big models are released, so to say, by big companies and all these scientific institutions that are doing research on LLMs are actually playing around with those models that were produced by these big tech companies. So that's shifting a little bit, I believe, the industry and the way in which research is being done as well. On the other hand, there's an effort that I believe that we should keep pushing as part of the industry as well, which is the open source or open sourcing these algorithms, these models. Meta, for example, or Mistral are two of the companies that are releasing the models that they are training. They are sometimes even releasing the code that they used for training. I read a few articles a few weeks ago about companies that are releasing the training data sets that they used for that. And I really believe that's important from many perspectives. One of them is that we need to audit these algorithms. We need to understand how they work and how they were trained, because we are talking about the technology, and I would love to hear your opinion about this as well. we're talking about a technology that is going to change the way in which we work, the way in we inform ourselves, the way in which we know new people, and more. So learning about the risks and the biases and all the problems that might be hidden on those algorithms, I believe is very, very important. If you just package that around the product and you just provide access to users, as OpenAI has done with ChatGPT, then you are hitting the world with a hammer. But it's an unknown hammer. It's something that we don't know how it works internally. So yeah, I believe that going back to your question, Vico, unfortunately, we are seeing that big tech companies are the owners of the LLMs. We are seeing efforts to open source these algorithms, and these efforts have are grounded in this idea of creating safe and sound AI. But the owners are those big things, those big groups. So we have to think about it. But I would like to know, what do you think about that point in particular?
I have mixed feelings around this, and I'm going to be completely honest and straightforward this. So we need, actually, as you said, there's a demand of there's an investment that needs to be done. So therefore, I understand that the structures and dynamics of our current world ended up making these basic big companies taking up on this. This also was a big bet too, right? It was at some point that it flourished. But I do agree a lot on, hey, this is a fundamental shift, not only in it's a new technology, is shifting the way we engage with technology, how we interface with our daily tasks in general, how we might even, we've seen some few gadgets that are bringing this technology really into our daily lives, and how it could transform completely, not so much in the long term, but really like midterm, actually even our own cognitive pathways, and where do we put the most effort. So it's going to have a huge impact, and seeing efforts around its safety and to understanding biases, and allowing also to build specific models that are more aware of the context, that we were saying, and that they would take nuances into consideration, will definitely be something that I would like to see, because I think impact of these technologies shouldn't lay on the hands of a few, but it should be watched by all of us that are working with this new technology.
Yeah, at the same time, there's another factor, which is if we want to innovate with this technology, it's important to have access to it, because we cannot let these big companies to be the only ones with the big, good ideas. The good thing is that they are releasing somehow their models. They are providing us with access to their models through APIs. That's the common thing. We are seeing that there's a new startup every second appearing that is just connecting to OpenAI's API and doing something with that. And that's fine. I mean, that's a very important thing. And as you said before, they made investment. They have bought all these machines for running the algorithms. But yeah, I think that from an innovation perspective, it's also important to release these models, because someone will come up with a great idea for solving a new problem. Sorry, but Calde, I want to hear your opinion as well. Sorry, I interrupted you.
Well, I think that I'm totally agree with you in this sense. I think it's really important to be able to understand what the models are producing, and for innovation especially, it's like important to understand how they work internally, right? At the same time, that's a lot of effort, right? And that means like having access to a lot of information, dedicating a lot of resources to it, right? So it's at the same time it's a difficult thing to do. And I was thinking that it's difficult. Maybe it's more for the ethics part, but it's difficult in the sense of what this can end up enabling. It's like something that I don't think we know, right? It's not something. It's part of the unknowns. And I remember what happened with the ethics team at Google. I'm thinking on that part. So they released a paper about the problem of these things getting too big. I'm talking about this stochastic parrots. Yeah. So there are like a lot of implications, really. I would like to, maybe it's for the ethics section, but I don't know. We can go long with that.
Yeah, definitely. I really believe that. Well, that paper that you were referring to was focused mostly on something that I try to push every time that I have a conversation around LLMs and how they work, which is that they are unable to reason. They are not intelligent at all. They are very good in mimicking something that resembles intelligence, but they are not intelligent by themselves. They are just producing outputs in a format that is pleasant to read and that looks nice for us. They are not smart at all. And that specific paper that you're talking about introduced this idea of a stochastic parrot, about something that is able to produce outputs that look nice, but in the end, they are just sampling from a probability distribution. And that of course means that the output that you will get will look nice, but it doesn't imply that you have reasoning contained there. And I think that we can talk more about that.
We could do a whole episode about this, actually. Yes, we could go for hours. But for the sake of stream back a little bit, and we will go back onto this conversation. This is cool. And if you really would like us to discuss more, do send us a comment and let us know, and we can dive deeper in another episode, actually. So do remember to do that if you're listening to us. But steering a little bit back on the topics that still we have left, and we have a few much more left, and we are not even the half of the episode by now. The other door that had opened was discussing for AI experts or product designers who may be familiar with other areas of machine learning, but not LLMs. What aspects of transitioning to LLMs should be mindful of, and how they can leverage the already existing knowledge for it. Can you walk us through that, Petra?
Yes. Well, I think that the nice part of working with LLMs is that for 99% of the applications, you don't need to know what an LLM is and how they are trained and this kind of information. I think that knowing that adds for the extra 1% that you're missing. But I think that all of us are able to innovate with AI right now, with LLMs at least, without knowing sometimes not even a bit about programming or something like that. You just need to be a good prompter. So I would say that the learning curve in this case is not steep at all. It's relatively simple. It's just a matter of learning some use cases scenarios and then try to map the problem that you have in mind into that specific scenario where you want to try the algorithm. So I would say that there are like two flavors or two different ways of working with large language models right now. One of those is using these models as meaning extractors, let's say, as semantic, just to collect semantics from pieces of text. And by that, you use an embedding model. And this is something, I think that's the most complicated, so to say, application, but it's not difficult to understand at all. It's just a matter of inputting a text, getting a vector, and then try to find similar representations and then make something with that. That's, for example, the component that we have in RAG systems, and we can talk more about that later on. But that's the most difficult application. I think that the easiest one is just prompting. By just learning how to prompt a machine learning algorithm, a large language model, then you can have a machine learning algorithm that solves a problem for you. And for prompt engineering, you just need to take a course online. It's not a big deal. It's just a matter of learning the patterns of the prompt and how they should be structured. We can even make a podcast out of that as well. You just need to sort your ideas in a specific way. In that specific way is exactly the way in which the LLM can, complete the message for you and produce the outputs that you need. So it's not difficult at all.
I was thinking maybe for those a little bit less familiar with this, we go into internet and we hear about prompting in so many places. But we have like the prompt and the prompt engineering. And there's a slight difference on the prompt we engage as users and prompt engineering for those trying to leverage LLMs. Do you mind giving that quiet to those less aware of it?
Yeah, sure. So, of course, both of them are connected by the word prompt, right? But the prompt engineering part is what is done offline, let's say. So imagine that you want, for example, make a large language model that is able to take a brief of a new and write a blog post about that, all right? So, all right, you have the use case already in your mind, and you want to use an LLM for that. What you need to do, and you need to spend some time, is engineering the instruction, this general instruction that instructs the algorithm to produce the output that you want. So, for example, you would say something like, you are a journalist that writes articles for a blog. You are receiving short briefs about, or briefings about, a specific thing that happened, and you want to produce a text with 3 paragraphs and 10,000 words, extending that briefing in a pleasant way or something like that. So this thing that I'm saying is basically the instruction, the prompt that you will use for the machine learning model to produce the output. And for that, you don't need to learn any coding or have any coding skills. You just need to sit yourself with a few examples and ChatGPT, not even the plus version, and try it there and see what you get. Once you try it with a few briefings and you see that you're getting the blog posts that you want, then it's just a matter of putting that inside a piece of code. And then the input will always be the briefing, not even the prompt itself, because the prompt will be hidden inside the code of your program. And you will need just to copy and paste the briefing into a text box, and you will get the output. So,
right, and you can decide which are the parameters, right? Which are the parameters of, like, for example, the length of the text or the tone of the text that you want. You can, like, when you're engineer a prompt, you can decide which parts the user or the UI is passing to the system as variables.
Exactly, because in the end, what you have is the UI in which you will decide the tone and things like that, will just fill some empty places that you had in your original prompt. So you can say, write this text in and leave that blank space in this language or whatever, and then you just choose that and solve it. One important thing to take into account is that these large language models do not know how to count. It's amazing because they can write poems, but they are unable to count. So if you tell them, write just 2,000 words, they are unable to control themselves. They will produce words and words and words. And sometimes they will stop in 2,000, but they don't know how to count. So take that into account when it comes to prompt engineering.
And they're based on math, right? So
Yep.
in the
Yeah.
they're math, but they can't like do these simple things.
Yes, they struggle to do complicated math, but sometimes they are much better to do that math than basic math. And there's another thing with LLMs, which is that they have so many parameters that they sometimes dedicate part of those to memorize some concepts. Memorizing in this context means that if you get this input, it's like an if clause. If you get this input, then produce this output, period. And sometimes they know how to multiply two numbers because they memorize that. By the way, just as we did when we were in school, right? So
I was thinking about that.
So fair enough, but it's amazing how they struggle with those simple things.
Great. We talked about prompt engineering, right?
Mm-hmm.
And then what will be like embeddings?
Well, embeddings, as I said before, they are a way to represent the semantics of not just a word, but also a piece of text. So they are becoming a key element in these applications that are known as RAG, Retrieval Augmented Generators. We are talking about systems that are basically designed around a knowledge database. So, for example, you have all the knowledge of your company as files or as a Confluence site or something like that, and you want to ask a question, or you want the answer to one of your questions. So the typical way to do that, and you guys can tell me more because you are product engineers, was just writing a few words in a search text space, and you got, I don't know, 10 or 20 places in which these words were being used, and then you basically try to construct the answer yourself. In a RAG system, the interaction is completely different, and that's fascinating because you just ask a question as if you did with a human being, and what the system is doing inside is translating your question into an embedding, and then look around the different sources of information for answering that question, and looking which one is the one that is closest to your question in the embedding space. By that, you collect the context. You collect the context that you would use as a human to answer yourself the question. And then you use that combined with an instruction tune language model to get the answer in a human-like way. And if you think about it, that's amazing. That's something new for us. It's redefining the way in which we search for things, and that's why most of the people are using right now ChatGPT, for example, for solving problems related with coding or things like that. Instead of looking up the documentation of a programming language to identify exactly how to solve this bug, they prefer just to put the bug in a piece of code and let the model detect by itself how to solve it. The thing that needs to be taken care of is that when you interact with something like ChatGPT, for instance, you are not using a RAG system. You're just prompting a large language model. So a RAG system is different than a large language model. It combines both the instruction tuned language model and the embeddings generator. But for example, when you use Bing search, you are basically using that. It's a huge RAG system that extracts embeddings from your questions and looks them up.
So now you were telling us about this RAG, retrieval augmented generation. I was thinking if you could walk us through some other of the most common applications for LLMs, because we led me thinking we didn't have to talk about RAG, but there are definitely some other applications that we'd love to hear your thoughts about. And we see many of
Yeah,
them, several products being used. So I think it's also a good way to spark ideas of those around there listening to us.
Yeah, sure. Some of the new applications that we are seeing are what are called few-shot learning applications. So we have already discussed what supervised learning is, what unsupervised learning is, what self-supervised learning is. Well, let's talk now about few-shot learning. So few-shot learning refers to the process of learning with only a few samples. It's like you have 2 or 3 examples, and then you have a model that solves everything in the context of the samples that you used as examples. So if you imagine that, that's exactly what you can do by prompt engineering a model. You can, for example, let's say that you want to do sentiment analysis on the answers that you, or not the answers, but the comments that you get about your product, for instance. Then the only thing that you need to do right now is to write a prompt, take the comment as an input, and ask in the prompt the model to produce whether this was a positive or a negative response. And that's just an example of the amazing things that you can do using this idea of few-shot learning. You just show a comment and say this was a negative comment. Then you show another comment and you say this was a positive comment. And there you are. Then you have something that solves the problem for you. And this is just an example, but you can do whatever you want. In Arionkoder, we have used large language models for things like that, like for determining the role, the engineering role that is more likely to be associated with this profile, for instance. And you just take a LinkedIn profile and you get the output based on that, or things like that are relatively easy to do with this idea of few-shot learning. Then there are other applications that are multimodal applications of large language models. When we talk about multimodal, we are talking about taking not just text as input, but also images or video or things like that. So you can imagine things that are able to detect the frames of a video that contain some information, some specific information, or when a character appears on a video, or things like that. Or even using or even these generative models that we are seeing right now, like Midjourney or Stable Diffusion or things like that. They are grounded in large language models and a diffusion model that is able to produce the output. And last but not least, we have these dialogue-tuned language models, these conversational AI that we are seeing deployed everywhere. Yes, everywhere. It's like the new way to interact with a computer is as a chatbot and writing questions and things in a text box. And yes, and this is basically changing the way in which we are doing many tasks. Like, for example, customer service. I think that 90% of current systems that are doing customer service or that relied on humans for customer service are now using chatbots instead, because it's just a matter of detecting when you need a human, when an answer is difficult to be produced by a machine learning model, and then connect a human with the system. But you can do it now in a very, very straightforward way. So that's, I think, the most easy to see application, but that's another application. There you have it.
Today, we're seeing many of these applications as chatbots still on the reading side. But there's also a few more into directly conversational speaking and directly getting. What's your thought on those more spoken tools and changing that type of interface?
Well, uh, that's another example of a multimodal application. So when it comes to talking with a computer directly, you are using a model that translates sound into text, and then you just connect the text with a large language model, and there you have the answer. Um, what really fascinates me is the fact that with prompt engineering you can also produce text or not just text, sorry, but code and instructions, and then you can run those instructions directly. And I think that's at the core of many products that we are seeing right now. We are seeing that, for example, in even in Microsoft Windows, you have now agents that can solve tasks for you with the operating system by just instructing something like change my screensaver, or you just produce instructions like that, and then you get the internally what the AI model is doing is producing not the code but the steps that need to be mimicked with code to produce the output that you are looking for. And that's amazing. But I have a question for you right now, which is how do you guys as product engineers and as product experts see this environment changing with LLMs?
Well, I think it's starting to being seen everywhere, and in a lot of cases, they are just like initial implementations that aren't too powerful right now, but are still interesting. And I think it's also what they are bringing for the future. And we can see that in a lot of marketing messages, really, like the way they present the tools, the LLMs and the AI tools. I think they try to convey the way that they are seeing this integration in the future, but it's just like a marketing promise for now. Like, for example, I'm thinking in Miro. I use Miro day to day. Every day I'm using Miro. And they have introduced like a series of features that had to do with adding, right? Like in AI. And the AI is supposedly to assisting you to solve things that they're, I feel that the outcomes are yet things that need to be refined, but
Mm-hmm.
they're already like exposing that tools in a way of learning, maybe on a way of showing what they can do, or maybe just like a, the rush and the fever for the new thing.
Yeah. um, and speaking about Miro, because Miro in particular is intended for graphic based interaction. Let's say we are just putting stickies and connecting them, and that interaction is quite straightforward. It's the same way in which we collaborate with a whiteboard, for instance.
Yes.
But do you believe that these features that they are adding right now based on language are useful, or do you think that it's like forcing a technology into something that doesn't need it at all? I don't have an opinion myself. I'm
No,
just
yeah, I have it. I
curious.
have it. And if it worked like the marketing promise, I think they would be awesome, right? And it would be like
Hmm.
really useful for us, because what we do when we work in Miro is we just like are trying to organize ideas. There are ideas
Hmm.
that we put into stickies, and that we do that just to visualize our thinking in small chunks, right? And then we try to put them into like a relationship. We do affinity mapping, we create flow charts, we try to put ideas together or separate them. And they are all like operations that could be really interesting for an LLM to solve, right? And at least to be like an assistant. But when you try it with an actual series of stickies, the output that you got is normally not what you expected, or you
Hmm.
want to do things with that. There is like a huge things huge thing, a huge topic there that is about like how you interact with this technology, like whether you expecting from it. And I think we should like keep from a perspective of a product designer, I think we should keep our promises a little bit more down to earth, like not promise
Yeah.
everything, that we solve everything, and maybe like a collaboration with users, and that would be like don't try to propose we are getting a magical solution. It's more like something that will get you in the middle of it.
Because I guess that there are some matters around how much your users trust this technology. If they start seeing that the outputs that you get are not exactly the ones that were promised, then that damage the credibility of your solution, right? It's like it creates a negative feedback, probably.
Yes, and I think that's a problem as product designers we have to think about, right? It's not that you just like are connecting something new and that thing does the magic. It's more about um, connecting this in a way that helps you to move forward with your magic. What are you doing that is your processing thought, right? But I'm sure this will change also in the future, and I'm really like expectant to see how this work for us in the future. I'm just talking of the things that I tried in Miro, and maybe
Mm-hmm.
for when I think, for example, for summarizing transcripts of interviews, that is something that we need to do because we have user interviews, we learn from users, and it's an interesting use case, right? Because if technology can summarize the main points of a conversation, it's another output and another perspective you can include. You have your own highlights, right? As a human, you already are thinking, oh, okay, this is important. This also was important. I heard
Mm-hmm.
about that in other conversations. So here we have a pattern here, but the technology could uh, add something, right? That is could be interesting, right? The generated summary could see things that you missed maybe, or it could
Mm-hmm.
add some extra points that you didn't consider.
I'm
Yeah.
actually excited to see specific applications in this regard, because today we have like general summaries, and I do agree it's really powerful to reduce time and get quick summaries. But I wonder if we couldn't have an even greater potential if we have LLMs like specifically trained around human behavior and even biased, and much more focused on looking for behavioral patterns in language and being aware of cultural context. That would be an interesting potential field for impacting product design on the ethnographic step when we do in research, because there's a part of making sense of the human behavior of when you're going through that interview, right? And when you see it and trying to understand, okay, what are the thought patterns this person is applying to when using a product actually. And I'm just really future thinking, and if I had to write a wish, imagine if we could do that, like find the patterns that are being applied, find the biases that are being applied. Hey, find, I don't know, cognitive even processes or
Mm-hmm.
fears around this interview.
And
I
at
don't
the
know.
same time, sorry, yeah, and at the same time, I think that that's one of the things that are still not solved, right? Because or maybe this is just like an idea I have, but models are trained based on human learnings. Human learnings have biases, so they have some flaws in that, specifically in that part, right? So it's I don't
Mm-hmm.
see how.
100%. For
Yeah,
me, it's where they have the biggest limitation, right?
yeah,
How
Mm-hmm.
much context they can manage around this, and how much understanding they actually do have around human behavior, or even their own bias. That it's like we're dabbling that. Usually, as humans, we do try to see what are the bias of others. It's even difficult to see our own bias. Try to ask machine learning model, large language model, to be self-aware of their own biases. We're like trying to ask the impossible there, without a doubt.
Yes, because there's no awareness in a machine learning model.
Yeah.
So
So
like
well, I
that's
don't know.
something.
We can leave that
Well,
for a future chapter, right?
yes, I think that we should do that. Yeah. And one thing that maybe it's good enough for the next episode, but I would like to at least grasp the surface about that. Don't you guys believe that now that we have AI and generative AI in particular, and LLMs in particular, don't you have the feeling that companies are trying to push that technology regardless the use cases scenario? Don't you think that they are desperate to put AI in their websites without
Well, it's a
taking a
new
moment to
thing. It's a new
yeah.
thing, right? And we have gone through this in the history of technology, like companies trying to incorporate new things in a way that it still doesn't work, but they are good marketing things. So it's part of the history of technology. It's a history of the internet, like the internet and the initial web pages that didn't have any purpose really. And then understanding how you can use as a tool for enabling information and easing processes, right? Like processes in different situations, and then web applications and web 2.0 and mobile applications, and like it's like that's part of the story of technologies. Like people start trying to add something to the product because that's the new thing, and later they
Hmm.
discover how to make the most of it. And I think we are in that initial phase regarding generative AI. They're all trying to figure out how, right? And they're trying to think of what cases can be useful and trying to incorporate the technology in that way. And still, we are not seeing like a lot of success. I mean, there is a lot of success for ChatGPT and some specific applications, but in general tools, I think we are just starting to scratch the surface, right? In the tools that we use day to day, the first use cases maybe aren't that good, or they
Hmm.
doesn't get to outcomes, but they will eventually do, and that will be like the when the platform shift really starts to happen, right? Because the
Hmm.
platform will change, will move everything probably to this new platform that is LLMs and generative AI. I have the
Hmm.
feeling that it's starting to that's starting to happen.
And if you guys have to recommend a company that is considering about adopting AI, um, if you have to recommend a way to do that, a way to start thinking about AI as a solution, what would you do?
Well, the first thing for me will be to think of it not as something that you just plug and play, because if you think
Hmm.
of it that way, you'll be like missing the point. You'll be trying to include it in a way that it's just like integrate in any way, and it will feel much worse than what we are seeing in these products like Figma and Miro. It will be just like
Hmm.
like an extra feature just to say you have it, right? You're doing
Hmm.
AI, and that's happening to a lot of companies right now. So, as any new product feature, it starts from solving a problem, right? As any product feature that is really contributing to a product is solving problems in a more effective way that other tools are doing. So in the background, it's just again about users, right? And how this technology could help with users' goals and needs in a
Hmm.
particular context in which they solve the problem in a more efficient way. So it's getting back to product design in that sense. It's
Hmm.
getting back to, and I think we need to understand more of models, and ML engineers need to understand more of product design in order to get to good solutions. So it's back to shared understanding, and maybe the goal of this podcast, right? Like feel like something that is shared, like the understand of the technology and product design with AI.
That's great. That's great.
In the end, it all dials back into having teams that are driven by the whole context. In the end, right? Are we being strategic in thinking what does my product actually solve for my users? How could I make this even better or more efficient with by applying them? And where's the more strategic part to actually consider it? It will depend a lot on the type of problem and the type of value proposition that I have as a product. But if the team in a 360 that is involved in exploring this is aware of potentials, possibility, and building this shared language of, hey, how do we go through translating that problem into a potential, at least proof of concept with this, and build a roadmap as we experiment too. I think this is a part of experimentation that some companies are going through that makes a lot of sense. But a lot of them are also rushing into without thinking on how does it actually connect with everything, right? They have like one test here and then it's off.
Yeah, because in the end, this is a solution for a problem. So you need to figure out the problem before trying to apply the solution. Otherwise, it's like you're putting the solution before the problem even appears. And before even knowing, maybe the problem is there, but if that problem is not adding value to the user, then it doesn't make any sense. But on the other hand, I get Calde's point, and I think I never sit myself to think in those terms, in terms of, hey, let's leave some space for experimentation, because sometimes even the users don't know that they have a specific pain, and they need to see that there's something new that appears that solves something that they didn't sit to think about. So it's like a trade-off, right, between the two things, between this new solution that I have and that I can use for so many things, and the pains that the users have and that I was unable to solve. So it's like connecting the dots.
There's an interesting paradox that some of the companies that have sat and heard what the customers said were the ones that ended up going bankrupt and disappearing, because only that they did was listening to what their customers said. So there's a dilemma there into being forward thinking. And this also made me remember this blog post that we have that is around the principle of Maya, the most advanced yet acceptable form of innovation you can put forward for users. So it's striking a balance, right, into creating new spaces, but also what people are ready for.
Yes, and it's also the new toy, right? It's the new toy that a lot of people wants to play with.
Yes,
it's like
100%.
Everybody wants to tinker with it, right? Everybody wants to get their hands dirty on it, and maybe like with a really simple application. And that happened with all kinds of technology. So I remember the 3D King application in the mobile phone era. That the beer that it was just like a drawing of it was an animation of a beer, and you can like play with it as if your phone was a glass, right, of beer. So you just lean the screen towards your mouth, and the beer started to also lean to your mouth, and it was just playing like the most dumb application of playing with the that particular thing that new phones, new technology has. And I think a lot of people are still on that stage, which is an immature stage. Most of people, most of us, right? And we just have to find a way to apply it in a not only for playful things, but also for things that are useful. And that's starting to happen a lot.
Yeah, and the funny thing is that it's a technology that is easy to use. going back to the very beginning of this podcast, we are talking about just coming up with instructions. So I think that we as humans are really good at instructing someone else to do our dirty job. So I guess that in the context of innovating with large language models, it's just a matter of exploiting that side of us and coming up with instructions to get the output that we want. So yeah, I think that it's full of opportunities. But we are running out of time, so I would like to save us a few minutes to talk about the ethical implications or considerations around large language models and the kind of things that we as either as machine learning experts or product experts need to think about. My take on that is that, well, I think Biko mentioned that before. When it comes to training machine learning models, we are talking about data, and the data contains our biases. They are intrinsic. They're all the nasty things that we do in internet because we don't expose our faces there, are contained in the data that is there, and therefore is captured by the algorithms. So those biases, in my opinion, are something to be worried about. Also, the fact that these versions of AI that we are using right now are non-steerable, which means that they go wherever they want, and we cannot control where they are going. We can do that with filters that we need to put before the prompt. That fact really worries me a little bit. Also, the carbon footprint of AI is something that we need to be aware of. The fact that these big, humongous models are trained on GPUs that are fed with fossil fuel based energy. That's something that needs to worry us as a civilization. And also the fact that we are putting a technology that is so powerful in the hands of basically everyone in the world, as users, not as makers, but as users, might come up with some malicious use cases that we need to focus on. For example, now we can write fake news in a relatively easy way, and that's something that will help nasty people to create chaos and political disorders and things like that. And I think that we should be aware of that. But I want to know your take about the ethical considerations of AI.
Yeah, I think that this topic, this last topic that you commented, is one of the most worrying things, at least for me. I think the problem in the background is just what are the main goals that you are putting behind the technology, right? Are you like considering putting community goals in the front of it, like the society goals, users goals, or are you just like optimizing for business, right? That's like a consideration to make, and I think we have to go way beyond red teaming for that, like putting like a series of people to understand how a model can be used for bad stuff. That is the red team idea. So I have read about some people trying to do like extra things with that, like going the purple team, that would be how this could affect society as a whole, and how this could end up producing bad efforts, bad outcomes when trying to do something good. So it's really interesting, but I think this is one of the most relevant problems because we have this new technology out there, we can use it, and it can be used for harming activities, right? Things that are like dangerous to society itself.
Biko, what's your take on this?
I was thinking a little bit back of what I said at the beginning. We create representation of the world from what we learn and what we understand. Basically, information and the internet are more and more these generative AI, particularly large language models, with their ability to create content in a massive, huge amount of it, are creating a huge gap in our abilities as humans also to make sense of the world more and more, as we are becoming more wary of, okay, what's real, what's not. And there's a huge difficulty around this, not only around fake news, but how this actually accelerates really harmful activities and puts our whole security at risk. The first steps for anyone to target us in cybersecurity they will try to collect information about us. And actually, LLMs accelerate these tasks. They can actually automate the way they collect information about us and how they start to understand and learn from us. They're like the whole reconnaissance process is accelerated with this. But I'm also thinking of us as product developers and how this also opens a huge door into security, and how actually exploring code and finding vulnerabilities and hunting around that and disconstructing might in the future also be accelerated with applications like this. I wonder if we'll see anything like that. I know we're far from there, but I get a little bit worried also of that. But without a doubt, for me, the hugest concern is how we have handed out a massive capacity of building narratives around what's happening in the world. And those narratives we consume is actually how we create an image of the world. So it's a little bit my biggest scare, that we are all aware that the world we conceive in and how we understand what's happening around, it's not necessarily what we see, and more with these tools around. So being really critical and keeping our minds open to ask and poke around with the news that we come across, it's going to be critical. And hopefully we'll start seeing clear ways of tagging, hey, this was created with an AI, or things that will allow for traceability of the content of these tools, right? At some point, to be more transparent of what's this being created.
Yeah. Well, there's a lot that we can discuss about these, and probably some of these topics will be covered in the next episode. But I would like to thank you guys, Vico, Calde, and of course the listeners that are there. If you made to this point, that means that you have listened to our episode all the way to the end. So that's cool. Thank you very much for your company today. So in this show, we have covered the fundamentals about LLMs, and we learned a lot about how these models are trained and are reshaping our products today. In our next episode, as I said before, we are going to cover some new things about this. We're going to add a new element to the chain. So keep yourself in track. Please leave us a review on Apple Podcast and Spotify, or comment in the box below if you're watching us on YouTube. And remember that Chain of Thoughts seeks to build a community of product designers, developers, and AI experts to keep creating great digital tools for customers and users. So to keep this community growing, remember to like, follow, and subscribe to Chain of Thoughts, both in Spotify and YouTube and all social media, and share with your own followers using the hashtag Chain of Thoughts Podcast on X and LinkedIn. So you can also follow Arionkoder on these social media platforms to keep yourself updated about the show and our actions as a company. And yeah, this was Chain of Thoughts, the first episode. See you around.
See you
around.
Bye-bye.
This was Chain of Thoughts, an original podcast brought to you by Arionkoder, a product design and development company based in Boston, Massachusetts, that delivers specialized development and consulting services around engineering, product, and AI. Learn more about Arionkoder by following us on LinkedIn and X. See you soon for the next piece of the chain.